S theta is a square region with a given vertices plus minus theta comma 0 and 0 comma plus minus theta, and theta greater than 0 is unknown. XY follows the uniform distribution of S theta, and we have to check whether the four statements are true, that XY are uncorrelated, independent, and mod x plus y less than theta and greater than theta. So let me get back to this question. I have basically drawn the area of S theta first, which is this particular square. And you can observe that the equation of the areas of S theta, that is this line, this line, this line, and this line, these are given by mod x plus mod y equal to theta. You can check that out yourself. This, for example, this line is x plus y is equal to theta. You can figure out the other lines by yourself, and it will come out to be mod x plus y is equal to theta. These are the equations of the edges. Again, S theta is a region bounded by this thing, and within this region, in this region, mod x plus mod y is less than theta. How can you check that? Simply, you can take one point in this S theta, say the origin, and in origin, mod x plus mod y is 0, which is less than theta. So in general, mod x plus mod y is less than theta for all xy belonging to S theta. So C is true and D is false. So, and definitely we can just seeing that C is true and D is false. And obviously X and Y are dependent variable because their ranges are dependent on each other. X and mod x plus mod y cannot exceed theta. And in order to check the correlation, we compute the covariance between X and Y. Covariance of X and Y is expectation XY minus expectation X into expectation Y. Now, the marginal, sorry, the joint PDF of X and Y is given by this range is essentially the range of S theta, where mod Y lies between mod x minus theta and theta minus mod x, and minus theta uh, less than x less than theta, and 1 by area of S theta, since xy follows uniform distribution in the region S theta. Now area of S theta, you can observe, is 2 theta square. How can you obtain that? Just take one of these four right triangles, is area theta square by 2. So the total area is 4 times of that, which is 2 theta square. So here the 2 theta square is in the denominator, and you basically have the integral minus theta to theta mod x minus theta minus mod x dy dx. Now expectation xy is simply this integral, integrating the function and xy over this given range, and x, since x is constant in this integral, it comes outside, and this comes out to be y square by 2 running in the range theta minus mod x to x minus theta, which comes out to be 0. Since theta minus mod x whole square and mod x minus theta whole square, this subtract to be 0. So expectation xy is 0. And the marginal distribution of x is simply obtained by integrating the joint distribution over the range of y. So I just obtained it here, which is 1 by 2 theta square integral mod x minus 0 theta minus mod x dy, which comes out to be theta minus mod x by theta square minus theta x runs from minus theta to theta. And expectation x, we here basically have simply split the values of x in two halves, where x is positive and negative, and it comes out to be this: x by theta minus x square by theta square, and here it's x by theta plus x square by theta square. We do this integral, this comes out in this particular form, which ends up to be 0. So expectation x is 0 and expectation xy is 0 as well. So covariance xy is 0. So xy are uncorrelated. This is a very good example where x and y are dependent on variables, but they turn out to be uncorrelated. And so A and C are the correct options.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISI Mstat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISI Mstat, and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
The last question of today. So here we have a normal QQ plot, which is drawn using a large sample x1 to xn from an unknown probability distribution. And for which of the following distributions we would expect the plot to be convex, which is J-shaped. And we are given 4 distributions: beta, exponential, uniform, and geometric. Now, a QQ plot is convex or J-shaped. A QQ plot is convex or J-shaped if the distribution concerned are right skew. And you can check the 4 distributions. The uniform 0, 1 is obviously symmetric. Its PDF is simply 1 running in the range 0 to 1. And beta 1, 5, 1 is a left skew distribution. You can obtain the skewness, or you can simply observe the graph if you can plot it. Exponential 1, which has the highest density in the lower values and generally reduces after that, is the right skew distribution. And similarly for geometric half, it has the higher probability in the smaller values. Since obviously as you go on proceeding in the trials of geometric distribution, your probability of landing a particular value decreases. So from here we can see that B and D are the correct options. So you can take it as a fact or as a note that QQ plot is convex if the distribution is right skew for any distribution. Since we compare it to the normal distribution, which is not skewed at all, it's symmetric. So that's the end of the questions for today.